So I'm going to continue with the extra questions. Extra question 11. Write few examples of exothermic chemical reactions that you see in your day-to-day life. Write equations to illustrate the heat change. So there are many exothermic reactions that you see in your day-to-day life. So one reaction you can think of, the reaction of calcium oxide with water to produce slake-like. That is an exothermic reaction. So to write the equation, calcium oxide solid with water liquid will give rise to calcium hydroxide, that is aqueous, and heat will be evolved. That is one example. Producing, so if we write it, they have said write few examples of exothermic chemical reactions that you see in your day-to-day life and write equations to illustrate the heat change. So here it is quicklime dissolved in water to produce slake-lime. That is an exothermic reaction. Then what are the other exothermic reactions you can think of? Burning of fuels or combustion of fuels. Combustion of fuels are examples of exothermic reaction. Can you think of an example of a fuel? You can write any petrol, diesel, but for those you don't know the chemical formulae. If you are writing that, you have to just write the word equation. But here I will use biogas, combustion of biogas. Combustion of biogas, that is methane. So then if we write the equation, you all know the chemical reaction. Methane is gas. With that, we need to use oxygen gas. So there will be carbon dioxide gas and water vapor evolve. In addition to that, heat will be evolved. You can write the balanced equation as well. So you need to have 2 oxygen gas. So that is another example. Then what else can you think of? Acid-base neutralization reactions. Those are also exothermic reactions. Acid-base neutralization. So for example, we can write hydrochloric acid aqueous in the stomach with, let's say, magnesium hydroxide from the antacid tablet. I can just put it as solid, or it can be aqueous in the case of milk of magnesia. Here the reaction will be magnesium chloride aqueous plus water plus heat. So acid-base neutralization. So this can be in the stomach and the antacid tablet. So that is another example of an exothermic reaction. What is another exothermic reaction? The cellular respiration that takes place inside the cells of our body. That is an exothermic reaction. So here we can say cellular respiration. What is the equation for cellular respiration? C6H12O6, that is glucose solid with 6 oxygen gas, giving rise to 6 carbon dioxide gas, H2O liquid, and energy is released. So these are all examples of exothermic reactions. If you go back, you can see the first reaction that I have given, calcium oxide solid, that is quicklime, dissolving in water to produce slake lime. So with water it gives calcium hydroxide and releases heat. Then the second equation, you can see here combustion of fuels. For example, combustion of biogas, that is methane, CH4 gas plus oxygen gas giving CO2 and water vapor, and heat is released. Again, if you look at the acid-base neutralization reaction, hydrochloric acid aqueous and usually magnesium hydroxide solid in antacid tablet, or it can be aqueous in milk of magnesia giving magnesium chloride aqueous, water and heat. And finally, the cellular respiration where glucose reacts with oxygen to release carbon dioxide, water and energy. So, in addition to this, I am sure you can think of many other examples for these exothermic reactions. So, with that, I will move on to the next question. Write few examples of endothermic chemical reactions that you see in your day-to-day life. Write equations to illustrate the heat change. So, same as before, we need to write examples as well as the equations. So, what are the endothermic reactions that you are familiar with? Again, the thermal decomposition reactions. So, here the first example we can take as thermal decomposition. So, when we say thermal decomposition, as an example, we can take calcium carbonate solid. When you supply heat, so as I told you before also, you can write heat on the arrow or you can write it with the reactants. It decomposes to calcium oxide solid and carbon dioxide gas is released. So, this is limestone and this is quicklime. That is one reaction. Then what else can you all think of? The dissolving of ammonium salts in water. Dissolving ammonium salts in water. So again, as an example, we can take ammonium chloride, NH4Cl, solid with water liquid. We have to put heat here. This will give rise to ammonium chloride aqueous. Dissolving of ammonium chloride solid in water. That is another example. Similar to that, students, you can think of another example. I have discussed this before with you all. Glucose, something that you use commonly. When you are sick or when you are doing sports activities, we use glucose. Glucose dissolving in water. That is also an endothermic reaction. So, here C6H12O6, that is solid, plus H2O liquid. This is just the dissolving. So, C6H12O6 aqueous. This is liquid. So, glucose dissolves in water to give glucose solution. That is also an endothermic reaction. So, here I have given three different endothermic reactions, students. The thermal decomposition, for example, calcium carbonate being heated, giving rise to quicklime, then dissolving of ammonium salts. I have taken ammonium chloride, you can even write urea. You know the chemical formula of urea, CONH2 twice. So that with water absorbs heat and forms the aqueous solution. Then glucose dissolving in water, that is also an endothermic reaction. So here also heat will be absorbed. heat will be absorbed by the reactants to form the solution. All these are examples of endothermic reactions. I am sure you can think of other reactions as well. So with that, I will move on to the next question. Extra question 12. Draw suitable energy level diagrams for the heat changes that take place when solid sodium hydroxide dissolves in water and solid ammonium chloride dissolves in water. So, two solids, you all are familiar with these reactions. We have done this in the lab. Sodium hydroxide, when it dissolves in water, heat is evolved. So, it's an exothermic reaction. Whereas ammonium chloride dissolving in water is an endothermic reaction. So, that is what we have to show here, students. I will write the two reactions. The first one is sodium hydroxide solid with water dissolves and forms NaOH aqueous. At this point, heat is evolved. So, this is an exothermic reaction. Whereas dissolving of ammonium chloride solid in water, there the reactants absorb heat and give rise to the product, ammonium chloride solution. So, this is an endothermic reaction. Now, we are supposed to represent this using energy level diagrams. You are familiar with energy level diagrams, students? So, I will draw the two diagrams side by side. Then, it's easy for you to understand as well. One diagram here. So, this is energy. You have to always label this axis. And for convenience, we'll use different colors. The first one, sodium hydroxide dissolving in water, it's an exothermic reaction. So, the reactant has more energy, products have less energy. So, NaOH solid with water liquid forms NaOH solution. And during this process, there is energy is released. So, that is the exothermic reaction. Now, if we draw the endothermic reaction, again this is energy and the reactants and the products. Now, here heat is absorbed. So, the reactants, that is ammonium chloride solid and water, have less energy compared to the product, ammonium chloride solution. Heat is absorbed. Energy is absorbed. Is this okay, students? So, this is an exothermic reaction, that is an endothermic reaction. So, sodium hydroxide dissolves in water, ammonium chloride dissolves in water. I am sure you also drew the correct energy level diagrams. With that, I will move on to the next one. Extra question 13. Chemical equation for cellular respiration is given below. So, you know this equation, glucose C6H12O6 solid and oxygen, that is 6O2 gas, react to give 6 carbon dioxide gas, 6 water, that is in the form of liquid, and their energy is released. So, that is the chemical equation for cellular respiration. The first question, is the reaction exothermic or endothermic? What is it? Is it exothermic or endothermic? Here you can see energy is released. So, that is exothermic reaction. Exothermic. Exothermic, or you can say exothermic reaction. A very short answer. Then the next one. Draw an energy level diagram to illustrate the heat change associated with the above reaction. So, you have to draw an energy level diagram for an exothermic reaction. But here, you need to write the relevant reactants and products. So, here again, the energy levels for the reactant and product. This has to be labeled as energy. What are the reactants there? Reactants are glucose and oxygen, and here they have higher energy. So, C6H12O6 solid plus O2 gas, and there were 6 oxygen gas. And what are the products? 6 CO2 in the form of gas plus 6 H2O in the form of liquid. In the equation, they have given it as liquid. So, whatever the physical state that is given to you, you have to use it here. So, then there is release of energy. Energy is released. Energy is released. Those are the information that you have to include in the diagram. You have to write the reactants, the products, and you have to say whether energy is released or absorbed. And you can see here the direction of the arrow. So, this represents the exothermic reaction, that is the cellular respiration. I am sure students, you also wrote the correct answer as well as drew the correct energy level diagram. With that, I will move on to the next question, extra question 40. Chemical reaction of extraction of iron is given below. An Fe2O3 solid, you all know what that is hematite, that is the O that contains iron. Then there is a substance A solid and there is coke. So, you are familiar with the raw materials of extraction of iron. What are they? The iron ore, coke and limestone or calcium carbonate. So, here, although A is not identified for us, you know that it is calcium carbonate or limestone. And there, when we provide heat, iron can be extracted. In addition to that, you all know the slag is the byproduct, but that is not given here. Let's look at the questions. Is the reaction of A in the above exothermic or endothermic? So, they are referring to the reaction of A. What is that? Is it exothermic or endothermic? It is an endothermic reaction. Why? Because it's a thermal decomposition reaction. So, here we only need to write whether it's exothermic or endothermic. So, you have to say it's an endothermic reaction. Endothermic or endothermic reaction. When we say thermal decomposition, we provide heat and decompose the reactant to simpler products. Then the next one. Write the relevant chemical equation for the reaction you mentioned above. So, that is for the thermal decomposition of calcium carbonate. What do we write here? Calcium carbonate solid. When there is heat provided, you have to write that in the arrow. On top of the arrow, we write heat, or you can use the delta symbol. What are the products? Calcium oxide solid and carbon dioxide gas. Those are the products. And here they have said relevant chemical equation. You have to make sure, or it's better to check whether it is a balanced reaction. Here can you see? It is balanced. Calcium carbonate solid giving rise to calcium oxide and carbon dioxide gas. Then the next one. Draw an energy level diagram to illustrate the heat change associated with the above reaction. That also you all know. Heat change associated with the reaction. So here this is energy, and now you have to write the reactants and the products. What is the reactant? Calcium carbonate. Since it's an endothermic reaction, reactants have low energy. So calcium carbonate solid is here, and the products calcium oxide solid and carbon dioxide gas, they have higher energy. So how does the reaction proceed? With the absorption of heat. And you have to mention that there is heat absorbed. Heat is absorbed. So those are the things that you have to include in an energy level diagram. You have to show the reactants, the products, and you have to say whether heat is absorbed or released, and you have to label the energy axis. So I am sure you also did this correctly. With that, I will move on to the next question. Extra question 15. During an activity carried out by a student, there was an increase in temperature by 5 degrees Celsius. So the temperature increased by 5 degrees Celsius. When 100 centimeter cube of NaOH solution was mixed with 100 centimeter cube of HCl solution. So two solutions, the base and the acid. So you all know it's an acid-base neutralization reaction, and we know the volume and the temperature change. Write the balanced chemical equation for the reaction between HCl and NaOH. So balanced chemical equation. What do we need to write? Hydrochloric acid, that is in the solution form, and NaOH again in the solution form, giving rise to sodium chloride aqueous and water liquid. So here we don't have to mention whether it's exothermic or endothermic. You are only writing the balanced chemical equation. So it is balanced as well. Hydrochloric acid and sodium hydroxide giving sodium chloride aqueous and water liquid. With that, I will move on to the next question. Calculate the heat change associated with the above reaction. So you all know the equation that is used to calculate the heat change. What is that, students? Q equals mc theta. So here we need to have the value for the mass of the mixture. So there you know the volumes. Then you have to convert it to mass. So we will do that now. So first, you know the total volume. You can calculate it. 100 centimeter cubes of HCl plus 100 centimeter cubes of NaOH. So the total volume is 200 centimeter cube. Then what do you have? You have the density of water. So density equals what? Mass over volume. So if we rearrange, we can get the mass of the solution, that is density into volume. What is the density? 1 gram per centimeter cube. That is given to you, density of water. And then the volume is 200 centimeter cube. So the mass will be 200 grams. Why? These two cancel off. So you know the calculation. Now that we know the mass of the solution, we can directly use the equation here. Q equals mc theta. So we know the mass 200 grams. Do we directly substitute like this? We have to convert it to kilograms. So that has to be converted to kilograms. So there it becomes kilograms. Instead of grams, we have kilograms. Then we need the specific heat capacity that was given to you as 4200 joule per kilogram per Kelvin. Joule per kilogram per degree Celsius or Kelvin. I have told you all both the units are same. For us it was given in per degree Celsius. Then what was the temperature change? 5 degrees Celsius. So those are the values that we need to substitute. And when you simplify this, these get cancelled off. Kilogram and kilogram minus 1. 0 and 0 you can cancel off. Degree Celsius and degree Celsius can be cancelled off. So you will have 2 into 420 into 5 joules. That will be equal to 4200 joules. If you like, you can further convert it to kilojoules. That will be equal to 4.2 kilojoules. So 4200 joules or 4.2 kilojoules. That is the heat change associated with the reaction. I will go back and we'll just go through the calculation. So here you can see, students, we need to calculate the total volume. 100 centimeter cube of acid and 100 centimeter cube of base. So the total is 200 centimeter cubes. That has to be converted to the mass. For that we use the density. So mass is equal to density into volume. That is equal to 200 grams. Then we substitute the values in the equation to calculate heat change. That is Q equals mc theta. So the mass has to be converted to kilograms. So you divide it by 1000. The specific heat capacity of water and the temperature change. So you get the value as 4200 joules or 4.2 kilojoules. I am sure you also did the calculation correctly. With that, I will move on to the next question. What are the assumptions of the above activity? So what did we assume there? One assumption, we assume that all the heat that is released during the reaction is used up to increase the temperature of the reaction mixture. What else? Since dilute solutions are used, specific heat capacity and density of the solution equals the specific heat capacity and density of water. So those are the assumptions. So here, if I write the assumptions, all the heat released from the reaction is used to increase the temperature of the reaction mixture. Since dilute solutions are used, the density and specific heat capacity of the solution is equal to the density and specific heat capacity of water. So those are the assumptions. Then the next question. Write the possible errors that can occur during the activity. What are the possible errors? So here we assume that all the heat that was released during the reaction is used to increase the temperature. But what is the possible error? There can be heat loss to the environment. That is a possible error. So one possible error, heat released by the reactants can be lost to the environment. So here students, it's not all the heat but only a part of the heat that is produced can be lost to the environment, that you can understand. And then what are the other possible errors? If we use concentrated solutions, then we can't assume that the specific heat capacity and density will be equal to water. So that is again an assumption based on the use of dilute solutions. So here we can say, if concentrated solutions are used, then the specific heat capacity and density of the solutions can be different from water. So for calculation, we can't use the values of water. So those are the possible errors. So here students, the assumptions, all the heat released from the reaction is used to increase the temperature of the reaction mixture, and since dilute solutions are used, the density and specific heat capacity of the solution is equal to the density and specific heat capacity of water. And the possible errors that can occur during the activity, heat released by the reactants can be lost to the environment. And also, if concentrated solutions are used, then the specific heat capacity and density of the solutions can be different from water. Is that clear to you all students? So with that, I will move on to the next question. How can you minimize these errors? How can you minimize these errors? We can use insulated cup and a lid so that heat is not lost to the environment, and also we can use dilute solutions of the acid and base. So here we can minimize these errors by using containers made of insulator materials. An example is polystyrene. So that is the first one. The second one, use dilute solutions of acid and base. Then the last question. What will happen if you use sodium hydroxide instead of the solution used? So you all know the heat changes of reactions depend on the physical state of the reactants as well as the products, especially the reactants. So in the activity they used solution. Instead of that, if you use solid sodium hydroxide, what will happen? The amount of heat released will increase. So what will happen if you use sodium hydroxide instead of the solution used? The amount of heat released will increase. Therefore, the increase in temperature will be higher. So that is what happens when you use solid sodium hydroxide. So I am sure students you were able to answer both these questions correctly as well. With that, I will move on to the next one, extra question 16. Write an equation to calculate the heat change of a reaction. That is a very direct question. You know the equation, Q equals mc theta. What is heat? Q, that is heat change of reaction. What is M? Mass of the reaction mixture involved with the heat change. What is C? Specific heat capacity of the mixture related to the heat change. And finally, theta, temperature change associated with the reaction. So they have asked for the equation. write an equation to calculate the heat change of a reaction. It's better if you can define the quantities or the data included in that equation. With that, students, I will move on to the next question. State the nature of reactions given below based on the heat change. So, you need to say whether they are exothermic or endothermic reactions. Mixing water with quicklime. What is quicklime? Calcium oxide. And it dissolves in water to give slake lime, calcium hydroxide. And that is an exothermic reaction. So, here this is an exothermic reaction. How about the next one? Producing quicklime by heating limestone. So, when you hear the word heating, it's thermal decomposition. So, it has to be an endothermic reaction. Endothermic reaction. Photosynthesis. In photosynthesis, light energy is utilized. So, that again is an endothermic reaction. Dissolving urea in water. You know that reaction. Heat is absorbed. Endothermic. Usually, the dissolving of ammonium salts in water, urea, all those are endothermic reactions. A piece of sodium reacting with water. That is a vigorous reaction, releases lot of heat. So, it is an exothermic reaction. So, you can see, students, mixing water with quicklime is exothermic. Producing quicklime by heating limestone, it's endothermic. Photosynthesis is endothermic. Dissolving urea in water is endothermic. And a piece of sodium reacting with water is exothermic. I am sure you were able to classify them correctly. With that, the next question. Extra question 17. Solid sodium reacts with chlorine gas to produce sodium chloride solid. 822 kilojoule per mole is released during this reaction. So, that is the amount of energy that is released during the reaction. Write the relevant chemical equation for the above reaction. So, here you can see solid sodium, that is Na solid, reacts with Cl2 gas to produce sodium chloride, that again is a solid. So, here you have to balance the chemical equation. So, you can see there are two chloride or chlorine atoms. So, that means we need to have two sodium chloride and therefore we need two sodium solid. So, two sodium solid with chlorine gas gives rise to two sodium chloride solid. That is the relevant chemical equation for the reaction. What is the observation that will help you to conclude that a chemical reaction took place in the above? How would you know that a reaction has taken place? From this, you can't really say what will happen. But here, with the data, you can see there is heat being released. So, then what will happen? The container will become warm, or you can say the temperature of the reaction mixture will increase. So, from that we can confirm that the reaction has taken place. So, the temperature of the reaction mixture and the container will increase. Then the next question, is it an exothermic reaction or endothermic reaction? What is it? It is an exothermic reaction because they have mentioned before that heat is released. Exothermic reaction. So, were you all able to answer these questions, students? I am sure you were. So then I will move on to the next question, extra question 18. Heat change of the reaction between calcium carbonate and hydrochloric acid is given as delta H is equal to minus 61 kilojoule per mole. I have mentioned to you all this. Delta H means releasing of or the change of heat energy. Heat energy change related to a chemical reaction that is given by delta H. When they give you minus value, that means energy is released. Heat is released. Plus is heat is absorbed. Minus is heat is released. So, is it an exothermic reaction or endothermic reaction? It is an exothermic reaction. So, here we need to say it is an exothermic reaction. Explain your answer. So, what would you say? Because with this delta H minus 61 kilojoules per mole means energy is released. So, delta H equals minus 61 kilojoules per mole indicates that 61 kilojoules per mole energy is released during the reaction. Write a balanced chemical equation for the above reaction. So, here the reaction is, we have to look at the question. Heat change of a reaction between calcium carbonate and hydrochloric acid. So, calcium carbonate, that is a solid, and hydrochloric acid, aqueous. You are familiar with these types of reactions, students. Calcium carbonate and HCl gives you calcium chloride aqueous plus H2O liquid and CO2 gas. So, when calcium carbonate reacts with hydrochloric acid, you get calcium chloride aqueous, water liquid and carbon dioxide gas. Is that okay, students? So, that reaction was an exothermic reaction. Why? Because the value was given as minus 61 kilojoules per mole, that is delta H, energy change related to the chemical reaction. And this is the equation for the reaction. I am sure you are also able to write the correct answers. With that, I will move on to the next question. Draw an energy level diagram for the above reaction. So, here again we need to label the axis. The axis has to be energy, and here you can see we need to write the reactants and the products. It was an exothermic reaction. So, then it is calcium carbonate solid and HCl aqueous. Those were the reactants. And what are the products? You can remember calcium chloride aqueous, H2O liquid and CO2 gas. And this was an exothermic reaction. So, here students, you can see these are the reactants, calcium carbonate and hydrochloric acid. Why? They have more energy, they release energy, and the products are formed calcium chloride aqueous, water and carbon dioxide. So, we have to show that there is change in energy taking place. So, from here to here, energy is released. So, we have to show that as well. Energy is released. So, this is the energy level diagram for the above reaction. With that, I will move on to the next one. Extra question 19. Illustrate an exothermic reaction and an endothermic reaction using energy level diagrams. So here they just want you to draw the energy level diagrams for exothermic and endothermic reactions. You don't have to give an example. So then I will draw two diagrams. So this is for one. This is for the second one. We have to label this axis as energy, and if it is exothermic, so this I will take it as exothermic. What happens there? Reactants have more energy, they release energy and the products are formed. So we have reactant here or reactants here and the products there. So in this, what happens to energy? Energy is released. Energy is released. Then the next one, if we take this as the endothermic reaction, there what happens? Reactants absorb energy and become the products. So reactants have less energy, the products have more energy. So when we need to show that, so what do you need to write? You have to show that energy is absorbed. Energy is absorbed. So here students, you can see the two common energy level diagrams. For exothermic reaction, reactants have more energy, products have less energy. So energy is released. For an endothermic reaction, reactants have less energy, products have more energy. That is why they absorb energy. Is that okay, students? I am sure you drew them correctly. With that, I will move on to the next question. Extra question 20. A group of students carried out an activity to determine the energy change of the reaction between sodium hydroxide solution and hydrochloric acid solution. So here it is sodium hydroxide solution and hydrochloric acid solution. They use the following materials for the activity. What are the materials? 50 centimeter cube of 2 moles per decimeter cube solution of sodium hydroxide. Again 50 centimeter cube of 2 moles per decimeter cube solution of hydrochloric acid. They have used 2 beakers, thermometer, glass rod and a styrofoam cup. You know the use of styrofoam cup. Draw a diagram to illustrate the activity. So here they want us to draw a diagram to show how the activity is carried out. There you can see students, they have only said a styrofoam cup. You can remember when we did the activity, I showed you all we can use one cup inside the other, that is the nested cups, so that there is very less heat loss from the reaction mixture to the environment. So here it's only one styrofoam cup. So we just need to show that one styrofoam cup. Then you need to have the lid. We need to have, this is the stirrer and that is the thermometer. So if you represent everything diagrammatically, that would be fine. So this is the thermometer, then styrofoam cup, the styrofoam cup will be with the lid, so you have to show the lid as well. And this is the stirrer, and here we will have the solution, the solutions. So that is the activity. You all know what to do. We need to measure the volumes of the two solutions, then we need to take the temperature readings of the solutions. After that, we transfer them into this styrofoam cup, and then we observe the increase in temperature. So we get the final temperature reading. So that is how we do the activity, and this is the diagram to illustrate the activity. Is that okay, students? With that, we will move on to the next question. Write the balanced chemical equation for the reaction between sodium hydroxide and hydrochloric acid. So you know the reaction. Sodium hydroxide, NaOH aqueous, and HCl aqueous gives rise to sodium chloride aqueous and water. So that is the balanced chemical equation. Write two glassware used to measure the volume of solution. What are the two glassware that can be used to measure the volume of solutions? You can think of the measuring cylinder. We can use volumetric flask, but volumetric flasks are usually used to prepare standard solutions. We can even use the beaker. So here, if it is 50 or 100 centimeter cubes, we usually use the measuring cylinder. Measuring cylinder. They have asked us to write two glassware used to measure the volume of solutions. There are other glasswares like the burette and pipette that can be used to measure volumes. Here, since we need to measure a certain fixed volume, we can either use the measuring cylinder or the pipette. You can remember the pipette. The pipette can be used to measure the volume of a solution. Then the fourth question. Calculate the number of moles of sodium hydroxide present in the solution used for the activity. So to do that, we will go back to the slide. Here you can see it's 50 centimeter cubes of 2 moles per decimeter cube solution. So calculate the number of moles of sodium hydroxide present in the solution. It is 50 centimeter cube and 2 moles per decimeter cube solution. So to find the number of moles, what do we do, students? We can use the equation C equals N over V. When you rearrange, N is equal to concentration into volume. What is the concentration? 2 moles per decimeter cube. And what is the volume? Volume is 50 centimeter cubes, but that has to be converted to decimeter cubes. So we need to divide by 1000 so that it becomes decimeter cubes. So here, if you simplify the two, you can see it becomes 10 over 100. That is 0.1 mole. That is the number of moles of sodium hydroxide present in the solution. With that, we will move on to the next calculation. I am sure you are familiar with this calculation as well. We have done this with the lesson, a similar calculation. So then, the next one, Write 3 assumptions used by the students for the calculation of the heat change of the reaction. 3 assumptions. What are the 3 assumptions? Can you all remember those? All the heat that is released during the reaction is used to increase the temperature of the reaction mixture. That's the first one. All the heat that is released during the reaction is used to increase the temperature of the mixture. What are the other 2? You can remember specific heat capacity of the solution equals specific heat capacity of water. Specific heat capacity solution equals water. And the third assumption, density, again solution equals water. So we assume that the specific heat capacity of solution is equal to specific heat capacity of water, and density of the solution is equal to density of water. So I have written it in a shortened form here, students. You can write it in more detail in your own words. I'm sure you can do that. And then draw a suitable energy level diagram to represent the reaction between sodium hydroxide solution and hydrochloric acid solution. So, an energy level diagram. You are familiar with the energy level diagram. You all know this is an exothermic reaction. So, this we have to label the axis as energy. Then we need to have the reactants and products. So, since it's an exothermic reaction, reactants are on top. NaOH aqueous, they have more energy, and hydrochloric acid aqueous. And the products, sodium chloride aqueous and water liquid, those are the products. They have less energy. So, energy will be released during the reaction. So, here energy will be released during this reaction. Energy is released. So, is that okay, students? You can see NaOH aqueous and hydrochloric acid aqueous, those are the reactants. Sodium chloride and water are products. They have less energy. That is why energy is released, and this is an exothermic reaction. Is this clear to you all, students? So, with that, I will move on to the next question, extra question 21. An increase of 10 degrees Celsius in temperature was observed when 50 centimeter cube of 2 mole per decimeter cube solution of acetic acid was mixed with 2 moles per decimeter cube calcium hydroxide solution. So, here the acid and base are different. Acetic acid with calcium hydroxide, that is the base. Calculate the number of moles of the reactants present in the solution separately. So, we need to calculate the number of moles of reactants. So, what are the reactants? Number of moles of acetic acid. To do that, what do we need to do? We need to multiply the concentration by volume, because you know concentration equals number of moles divided by volume. So, what is the concentration? 2 moles per decimeter cube and volume is 50, but we need to convert it to decimeter cubes. So then we have the value as 10 over 100, that is 0.1 moles. So that is the number of moles of acetic acid. The same way we need to calculate the number of moles of calcium hydroxide. Hydroxide, the same equation, 2 moles per decimeter cube into, you can see, 50 divided by 1000, again decimeter cubes. So when you simplify that, again you get the values as 10 over 100, that is equal to 0.1 moles. So that is what you were supposed to calculate here. Calculate the number of moles of the reactants present in the solutions separately. With that, I will move on to the next question. Calculate the heat change of the reaction. Specific heat capacity of water is 4200 joules per kilogram per degree Celsius, and the density of water is given as 1000 kilogram per meter cube. So to calculate the heat change, you know the equation, Q equals mc theta. For that we need the mass of the mixture. So here students, you can see they have given the density as 1000 kilogram per meter cube. So what do we need to do? We need to find the mass. To find the mass, what do? We need the volume, 50 plus 50. But this is in centimeter cube. So we need to convert it to meter cubes because the density has meter cubes. So to do that, we need to divide this by 10 to the power of 6. And we need to multiply by 1000, that is the density of water. So then what will happen? The power and 1000, this gets cancelled off. It becomes 10 to the power of 3. So we will get the value 100 divided by 1000. That will be equal to 0.1 kilogram. So we have directly calculated the mass in kilograms. Then we need to substitute in Q equals mc theta. What is m? 0.1 kilogram. C is given to you. You can see 4200 joule per kilogram per degrees Celsius. And you can remember students, the temperature change, it increased by 10 degrees Celsius. So when we simplify this, you will get the value as 4200 joules. Why? You can cancel off 0.1 and 10. Kilogram and kilogram cancels off. Degree Celsius and degree Celsius cancels off. So there you get the value joules. 4200 joules is the heat change associated with this reaction. So then we have the third part. What are the assumptions taken during the calculation? You all know the assumptions, students. What are they? One thing, there is no heat loss to the environment, or all the heat is used to increase the temperature of the reaction mixture. So that is the first one. All the heat released during the reaction is used to increase the temperature of the solutions. That's the first one. Then what are the other two assumptions, students? We assume that the specific heat capacity of the solution is equal to water. specific heat capacity of the solution is equal to that of water. And what is the third assumption, students? Density of the solution equals density of water. Density of the solution equals density of water. So those are the three assumptions. I am sure by now you know them by heart. Always we take these three assumptions. With that, I will move on to the next question. Write a method used to prevent the heat loss to the environment. How do we prevent heat loss to the environment? We use a styrofoam cup. So we can say use a styrofoam cup. Styrofoam or polystyrene. You can say polystyrene cup with a lid. Or else you can remember, students, when I did the activity I showed you all, we can use a calorimeter. Then the next one. So, what is the amount of heat evolved when 1 mole of acetic acid reacts with 1 mole of calcium hydroxide? So, you can remember, students, we calculated the heat change as 4200 joules and the number of moles of the reactants were equal to 0.1 moles. So, here they want us to calculate for 1 mole of acetic acid reacting with 1 mole of calcium hydroxide. So, here to calculate heat change for 1 mole. So, what do we need to do? We need to divide 4200 joules by 0.1 moles. So, the answer will be 42,000 joules per mole. For 4200 divided by 0.1 mole. So, you get the answer as 42,000 joules per mole. Explain how the physical states of the reactants and products affect heat change of a chemical reaction. You can remember that, students, when we use solutions, there is a certain amount of heat change. But for a solid to dissolve in water and form the solution, there is heat change involved. So, because of that, when you use a solution, there will be a certain value of heat change. Whereas, when you use a solid as the reactant, the amount of heat change will vary. So, that is how the physical states of reactants and products affect the heat change of a chemical reaction. So, if you need to explain that, the reactant in the aqueous state to become products, there will be a certain amount of heat change. But if the reactant was in the solid state with water, what happens is, for that to become the solution, there is another heat change involved. So, because of that, there is heat change 1 and heat change 2 both occurring together. So, this will lead to a higher value for heat change. That is what you have to explain here. So, I can say here, for the reactants to dissolve in water, there is a heat change. So here we can say, therefore, the heat change associated with a reaction depends on the physical state. Okay, students. So that was the last question, the extra questions for this lesson. I am sure with all the questions that we have practiced so far, you have a good understanding as to how you should answer questions related to this lesson. But keep on practicing to become more and more competent with this lesson.